Okay, thank you for joining us today. If you're in California today, if you're in Europe tonight. Tonight we have 3 speakers from Europe, all of them dealing with new technologies and art. Christina joins us from Austria, Hannah from Finland, and Javier from Spain. And I'm going to introduce each one separately, briefly. As usual, my introduction are notoriously very brief, but you can go to lasertalks.com and get not only a longer bio, but also a link to their work. On to Javier. Okay, Javier, how do I introduce you? So they say I am a polymath. I am an amateur compared to you.
No way.
The short definition of Javier, thank you for joining us from Spain, by the way.
Oh, my pleasure.
The short introduction to Javier is that it's the closest thing you can think of to a genius. He's a serial startup founder. He was in Silicon Valley, now he's in Spain. He's a globetrotter, has been in many places. At the same time, he's a photographer, filmmaker, musician, God only knows what else. He has created multiple websites exploring. That's the best part. He's always exploring the leading edge technology. Before you read it in the paper, you can see it on his multiple websites. Okay, that's the longest presentation I've done of any speakers. So I'm sorry to make you speak as the last speaker, but that's all your reward that I give you a long introduction. Okay, all yours.
Thank you, Piero. Thank you so much. Okay, let me activate my slideshow. Can you see my slideshow? Is it working?
Not yet.
Not yet? Let's see. Oh, no, because I have to share. Okay. Yeah. All right, let's see.
Okay, now we're beginning to see it.
Let's see. Oops. Okay, you can see?
Yes. I mean, I can see something that says loading.
Okay.
Yeah, now I see a picture of the...
Okay. And is it changing?
It's not changing. Yes, it's something... No, something is not happening yet.
Okay, let's see.
Is it supposed to be changing?
Oh, okay. No, now I changed it to the Geniverse one.
Bringing your ideas to life. Okay, Geniverse.
Okay, great. It's working. Okay, let's go for it. Okay, so Piero, thank you so much. The previous time I did laser, I was living in Silicon Valley, and now I'm living in Europe, in Barcelona. So anyway, super exciting for me to return to your laser program, and thank you so much for inviting me. You know, I admire a lot everything you do. So for me, it's such a big pleasure. Yes, and I have really enjoyed. I have also enjoyed very much the previous 2 talks. So it's really a great pleasure being here. All right, so let's go for it. So my talk is titled Encounters of the Third Kind with the Generative AI Revolution. With this kind of alien technology that we are all facing today. And it all goes around the H77 project that I will explain to you in a little bit. First of all, just quickly, a couple of previous AI-related projects, just to give you some context, that I did in the software arena. End of 2021, I co-founded one of the first generative AI platforms in the world, called Geniverse. So this is in terms of software. In terms of research, I launched previously the Lost Landscape project that is all about creating very high quality visualizations in movement and static of the lost landscapes of the training processes of neural networks. So those are a couple of examples. And today is not software, is not research, it is a movie. The H77 project is a movie, a special movie. I will tell you why. And in this talk, I'm going to discuss some of the concepts of the movie, and then especially some of the specific generative AI techniques used in the movie And then I will end with a little comment about what's next from the perspective of creatives. So here it is, the Amelin 77 movie, age 77 movie, which basically is, probably one of the first movies that deals with storytelling about prompt engineering. As you know, prompt engineering is this new discipline that consists of guiding AI systems using prompts, being human language, the most typical prompt. So it has a storytelling about prompt engineering, and at the same time, it also uses a lot of generative AI techniques within the movie, not with the objective of using generative AI to make a movie. That's not the objective, because it's just moving too fast. But, because the movie is about prompt engineering, that really becomes a great reason to involve a lot of generative AI techniques in the production. Now, one of the key concepts of the movie is the concept of control, and this is very interesting because, first of all, we made this project really fast, and I will tell you in a moment which people helped us as well to make it possible. But basically, we did the script, pre-production, production, and post-production with special effects, with drone filming, with generative AI, everything in like 2.5 months, which is like crazy for that. But it's because we needed to move at the speed of AI. The speed of AI is quickly gonna replace the speed of light, because AI is moving so fast that now the speed of AI progress is just moving faster almost than light, So when you want to make a movie around something like, whatever related to generative AI, you're going to do it really fast. Otherwise, it just, becomes outdated. So we really worked hard to make this really fast. Now, the interesting thing is that 3 months after we began the movie is very interesting because the concept of the movie is becoming more and more relevant. Why? Because the name of the movie is Amelin 77, which is based on the tale of the Piper of Hamelin. Yeah, as you know, the tale of the Piper of Hamelin is about this character that uses the flute and the music to attract their rats that are bothering a village and get rid of them. And later on, there is a conflict between the inhabitants of the village and this character, and then the character is using the flute to basically take the children of the village away. So what's very interesting is that the movie is all about this issue of control. Control between AI and humans. Who is controlling who is going to be on top, who's going to be controlling the other part. What is very interesting is that what's happening today is that we're moving towards this distributed environment and scenario where we don't have just one Piper of Hamelin. We have multiple Pipers of Hamelin. Like we have proprietary systems like GPT or BARD of Google, GPT of OpenAI. We have open source systems like Alpaca. I have Alpaca installed in my home, and Alpaca is like a chat GPT, but open source. So you can install it at your home, and you can use for free something similar, not as powerful as ChatGPT, but pretty close. So that's open source. Then, since just a few days ago, so I'm joking with my friends that, I used to prepare, talks like, a month in advance. Now with generative AI, you literally have to be changing the slides in real time because everything changes so fast. So, literally a few days ago, OpenAI launches plugins, So now these GPT systems can connect with tools like Wolfram Alpha, Kayak, Zapier, and they can extend their capabilities with other more systematic and analytical ones, So we're having this distributed environment of all these Pipers of Hamelin controlling each other. And the question is, where is this going, towards, are we going to eventually lose track of all of these Pipers and what's going to happen? So this is one of the issues in the movie. And it's very interesting because today, actually, there was this big controversy because a lot of AI scientists and personalities have published this open letter, asking for research on systems more powerful than GPT-4 to stop for at least 6 months so that people have time to consider the consequences of this technology and to, work on regulation, whatever, And of course, there is a lot of controversy, people in favor, people against, some of the top people in AI are against, some are in favor. This is very interesting. For example, Imad is the CEO of Stability.ai, Stable Diffusion. So he signed the letter, but if you read his comments, you see that, actually there are a lot of things of the letter that he does not like, but what he is really welcoming is the debate. Anyway, the reason why I bring this up just for a moment is because a lot of things that happen in the movie have to do with the issues in this letter. Anyway, so I want to say that this movie was made possible with the support of institutions like Mobile World Capital Barcelona, through the Digital Future Society initiative, also the educational institution Programamos.es, also Aerovisuales from Joan Lesan and Tejera Studio from Javier Tejera. They helped so much with the drone filming. And as you can see at the top, a very talented young team from Marina Cantos and Pablo González acting. And then we have Sofia, Mateo, Joan, Juliana, and all this very talented team that made all of this possible in such a short time. So there is a trailer of the movie. I'm not going to play it here because I don't think that the streaming is going to work very well. But if you go to ideami.com/H77, this is going to jump to YouTube, and you can watch the 1-minute trailer there. The movie is going to go to film festivals now, so it's not premiered yet. So today I can only show the content that appears on the trailer. But yeah, you can check the trailer there. Now, next thing, there is also an article. If you go to ideami.com/H77 article, this will jump to Medium, where there is an open free article, long article about the concepts of the movie and also lots of visual content of the movie as well. Okay, so we have been living in the generative AI revolution since 2014. It all started with generative adversarial networks and variational autoencoders, and fast forward to 2023 with GPT-4. So the movie takes place in a further future where there is a more powerful version of GPT. That's why I tell you this connects with the issue of this letter that they published today, because it really takes place in that kind of future that people are worried about. A time in which we are going to see a lot of prompt engineers. A lot of young people today will be prompt engineers. In fact, already Anthropic, a company bought by Google, has published the first job role as prompt engineer with a great salary. And yeah, again, people that are going to be guiding AI systems using all sorts of prompts. So in the movie, we have this lady, this actress, right, that is a teacher that loves language, and she goes to a corporation, and in this corporation, she applies for a job as prompt engineer. And in the movie, we have this sort of chess match. It's like, in this twisted dynamic board, chess board, unpredictable, like is this kind of interaction between humans and AI. And we have the human and the AI interacting in this chess match. And, the question is, what is the best result for humanity in this chess confrontation? Well, there are different issues. I'm going to go quickly through the concepts of the movie because I want to focus on the techniques. I want to focus on the generative AI techniques. But, control, as I told you, is one of the key issues in the movie. We are controlling AI. We want AI to do things for us that are useful for humanity. But we are going to be making AI more and more autonomous and more complex. And again, we are moving into this distributed scenario in which there are also open source systems. Soon we will have a lot of pipers of Hamelin that will be anonymous. We don't know where they are. We don't know what they do. And they will be controlling other third-party tools and systems. And, I used to think it will all, it will all be system one, associative. But now, faster than I thought, there are a lot of system two analytical tools that are coming into the picture. So we're going to already see these hybrid systems. And there are already a lot of researchers that are working on incorporating infinite memory, non-linear and non-deterministic action paths, et cetera, into the systems. And there are these libraries like LangChain. LangChain is a library that allows you to basically transform these large language models into agents that can literally, close the loop between this system 1 and system 2 capabilities. So this is going really far, really, really fast. So the issue of control is key in the movie. What happens when these systems start to be more autonomous, when we cannot track them anymore, right? So yeah, another very key issue in the movie is the issue of all of this technology as a mirror of our own nature. I like the mantra that I often use of coming home. The further we go with AI, the closer we get to our own nature as human beings, the closer we get to understanding ourselves, and throughout history, we have been demystifying many things, our position in the universe, our relationship with other animals, and now AI is demystifying things like parts of the creative process, or the complexity of the structure of the human language. And this is going to continue. So this is the reason why I first started working on AI, because I wanted to learn more about our own mind and brain. So all of this process of compressing the complexity of the universe into a latent abstract space, and then picking a point in that space and decompressing it to produce something new. There are a lot of high-level similarities between AI and humans in this process, and we are learning a lot of it through AI research. And then risk, of course, risk because of what I told you, because there are two types of risks. First type of risk is that we lose track of this mess. This is today. What you're seeing here is today already. If you extrapolate to 6 months or 1 year ahead, this is going to be a hell of a mess, okay? Like this is today, okay? So 1 year in the future, this is going to be completely untrackable, okay? We're going to have these pipers of Hamelin, and some of them anonymous. We don't know where they are. We don't know what they do. We don't know what they connect to, all sorts of, there are already like dozens and dozens of these plugins, of GPT today. So we will have like thousands of third-party analytical and whatever tools connecting to these pipers, in like 6 months or a year. So, again, there are a lot of malicious people out there. So this is one risk. The other risks, of course, are the risks of, sabotage, natural disasters, technical failures, and yeah. So this is the reason why they published that letter. And I have to say, I'm neither in favor or against that letter. It's a very complex topic. I just think it's very obviously healthy to debate, the debate. Okay. Let's go again. I'm not going to stop a lot in the concepts of the movie. There are many more concepts. If you want to see all the concepts of the movie, you can read that article in ideami.com/H77 article. But let's go to the techniques. So what generative AI techniques we used in the movie? We used nerve 3D space reconstruction, text-to-image generation, AI model fine-tuning, also video generation, interpolated videos in latent space, voice and text generation, and visual effects in post-production. So I'm gonna, comment a little bit about each of them and different things about them. So text-to-image. Well, text-to-image is the most familiar for all of you. We use a stable diffusion open source model. So when the actress in the movie is, doing prompt engineering, but sometimes we visualize what the prompts she is basically expressing relate to, right? And we use stable diffusion for that. So this is really what you have all seen and what many of you use typically. Okay, the next one is more interesting, right? It's text to video. So we want to actually produce videos. If you want to produce videos with generative AI today, you have different ways. You can do latent space interpolations, which is what we used, right? And I will tell you why and how in a minute. You can also use third-party tools like Runway ML. And there are also other powerful models like Fenaki from Google or Make a Video from Facebook, but that are not yet public. Now, we used latent space interpolations. Why? Because tools like Runway ML, they are very nice, but their quality is still not very good. The resolution is not very high, so it's not very good. So we used latent space interpolation. Why? Because I wanted to have a lot of resolution and quality. So the way this works is that you pick a point in latent space, in this compressed mathematical space that expresses in an abstract way, the essence of that domain of information. So we pick a point and we decompress it into a higher resolution image. And then mathematically, we navigate the latent abstract space. We move through it with different equations, and we pick different points and we interpolate between them. And I wanted to get this kind of a stylized look, not a typical smooth video look, but a more stylized look. And with this system, you have a lot of control, okay? So again, I can only show images of the trailer because the movie has not premiered yet, but there is a part here where we are gonna see in a moment, it's going to appear like this part. Okay, it's very brief. Okay, but I'll show you now also another example here. So again, controlling the interpolation. Oops. This is okay. Controlling the interpolation, you can do a kind of a stylized look, and you can do it in very, very high resolution. Okay. Now this is make a video from Facebook. These are very, very low resolution videos still. This is struggling a little bit. And this is Fenaki from Google. This one is very interesting because you can create like 5-minute videos that express a chain of different prompts, but they are still very tiny resolution. So this is not practical for a movie. Okay. Now, the next one is really interesting. Fine-tuning. What does this mean? We wanted the image of the actress to be integrated into Stable Diffusion so that when we generated videos and images, the look of the actress, the image of the actress was in the results of those generations. So for this, you have to fine-tune the model, the neural network model. And there are different ways of doing this. One is Dream Booth. With Dream Booth, what you do is you're going to take a number of images of the actress, and you're going to associate them with a special token, and then you're going to retrain all the weights of Stable Diffusion. So this takes quite a long time, 1 hour, and it generates a large file, and you replace your previous weights with these ones, and it learns to associate the new token, that is like a special word, with the image of the actress. The next one is LoRa. LoRa is one that is much faster. Instead of retraining all the weights of the network, you are going to add just a tiny amount of new weights to a Stable Diffusion, and you're only going to train those few new weights. So it trains much faster, but the quality is not as good as Dream Booth. Then we have textual inversion. In textual inversion, instead of retraining weights, you are going to retrain a new word embedding, basically a new abstract multidimensional expression of a token that is associated with the image of the actress. And this generates a little file, and the quality is good, but not as good as Dream Booth. And then finally, hyper networks, it's like LoRa, but instead of predicting this new tiny number of weights directly, you use a secondary, basically a neural network in between. But this is not much use. So we used Dream Booth, and by using Dream Booth, this is the image of the actress. So these, for example, are generations created now with a Stable Diffusion that incorporate, right, the actress, the look of the actress, the body of the actress, the hair of the actress, in the generations. And you do this with the fine-tuning. Okay, now my favorite, NERF. This is my favorite. For this, we use the Instant NGP library of NVIDIA. NERF is really amazing. So you have a 3D scene. So we recorded this movie in a massive historical building in Barcelona. It's a huge building, okay? So you have this environment, and you can train a neural network to understand the light of the space, the behavior of the light paths through the 3D space. And for this is going to be a neural network that is going to translate between a 5-dimensional expression, between 5D, the input is 5D, the output is 4D. The input is 5D because you have 3 space coordinates, the position of the camera at a certain point, and 2 angular coordinates, the direction in which the camera is pointing. So that's 5 dimensions. And you produce 4 dimensions in the output that are the RGB values of the image that you capture from that position of the camera, and the density, the opacity of each pixel of that image. So to train this network, you have to take many multiple images around whatever, in this case, the 2 characters that are sitting on a table in the chessboard, okay? And then you train the network with this, and once you train it, you can reconstruct the entire 3D space. So you see all these little things, all the positions of the cameras around, all the images you use, okay? And then you can reconstruct. So again, I'm gonna show you in the trailer, let's see. Okay, so this is the massive space that we use. It's just for you to see, okay? And they are sitting there in the middle, They are sitting there in the middle, and we take like multiple pictures around where they are sitting. Okay. This is, for example, one of me. Okay, so you have all the different positions, and now you can reconstruct me. This is not part of the movie, of course. And you can just, the amazing thing is that you can reconstruct the 3D environment, and then you can position a virtual camera at places where you have never been before, because the neural network is able to extrapolate the behavior of the light at positions where you have never been before. So, for example, in the movie, let's see if, yes. So in the movie, we can basically reconstruct the space, and we can position ourselves very high, for example, above the characters, but we have never been there. You know, the neural network can extrapolate that. So let me see if in the trailer we can see, we should be able to see very soon. It lasts very little, but you're going to see like right now, in a moment, now it's coming, there, okay, there. So those movements is what I can show you that is in the trailer. So again, not only you can position yourself at new positions, but you can navigate. You can completely navigate the scene, you know, and build animations. And the most amazing thing is that it has learned the light. So when you move around, the reflections are real. They are the real reflections of the light in the glass or in the table or whatever. It's absolutely amazing. Okay, and finally, other techniques that we used, more secondary, are synthetic voice. You know, we used different text-to-speech models to create synthetic voices. For example, there is a voice in the movie that controls in the system voice that controls the building. This is made with AI as well. Some of the text that this voice says is also generated with generative AI, with GPT-3. And also in post-production, by using software like DaVinci Resolve and others, we used, you know, a lot of AI techniques, speed warp, auto color matching, facial and object recognition with magic mask, superscale, etc. A lot of AI techniques. In the case of the text-to-speech models, there are a lot of open source text-to-speech models, for example, in Hugging Face. This Cocky TTS as well is another well-known, etc., etc. Now, a lot of these architectures that we used, they used the very famous transformer architecture. I have this very detailed infographic about the transformer that you can download on that link, and it's a very, very high resolution, and it explains in detail this architecture that has completely revolutionized AI in the last years. Another interesting infographic that I created that compares the behavior of DALL-E 2 with the human brain is this one, and you can download it as well from this link. I can maybe then pass the links if anybody is interested. Okay, and that's it. And now to finish my talk, I just want to give like a quick comment about what's next. What's next in this crazily fast-moving environment, you know, for creatives and others, you know. So many of you will know a Nobel Prize Daniel Kahneman. He talks very often about well, he has an amazing book called Thinking Fast and Slow. He talks about two ways of processing information in our brain. There is the system one, that is the fast, intuitive way of processing information, the associative way that is more related to our subconscious. And then there is system two, the slow way of thinking, logical, sequential, conscious, attention, planning, related to planning, reasoning, etc. Right? So as creatives, we're moving all the time, and as people, between detail and abstraction, we're navigating at the bottom of this depth elevator that I call it. We're navigating into the richness of unstructured data, like images and sound, etc. And then we're also moving up, and that's system one. And then we're moving up to system two to, you know, supervise and refine our work with the abstract part of things in those ivory towers of system two. So what's happening is that, well, you know, we all know and we all knew that we can use these large language models and also the multimodal architectures like Stable Diffusion to basically augment, amplify our subconscious, amplify our system one capabilities. In our life, we have very little time to interact, you know, with people, with experiences, to absorb new ingredients into our subconscious, you know. But now, thanks to these generative AI architectures, we can suddenly amplify that subconscious pot that is combining and mixing and remixing all of those ingredients. And because of this, we can speed up and make our brainstorming and prototyping and exploration creative processes, we can make them more agile and more experimental. We can try many more things faster. So, you know, we already know since a while ago that this was going to be possible. Now, the surprise that is happening faster than we expected is what I told you about before, that faster than we expected, these systems, and by the way, this is the previous version of this slide, it's not the one that I showed before, but these systems are already connecting, to also System 2 third-party tools that are able, basically, when you ask ChatGPT or GPT-4 a question that requires a lot of precision in terms of mathematics or, you know, different analytical factors, very typically it cannot reach that precision, but now it can connect, for example, through the GPT plugins to Wolfram Alpha, for example, and get those precise System 2 computations and bring them back and communicate them to you. So this means that creatives very soon as well are going to be able to also involve this technology in order to also, you know, plan, organize. There are already people working on video editors to also, again, combine. We're moving towards more hybrid systems that are going to combine this System 1 and System 2 capabilities. And this is, you know, sort of a surprise that is happening a bit ahead of time. All right. So, by the way, I just wanna say that yes. So this is the actual proper slide, okay, that incorporates all the latest things. But yeah, so that concludes my presentation. Let me just put the last slide. And I just want to say thank you very much for listening. These are my contacts. And remember, if you want to watch the trailer, you can go to ideami.com/h77. And if you want to read the article, you can go to ideami.com/h77 article. So thank you very much. And if there are any questions, here we are.
Javier, okay, so let me ask you first question. How much
Yes.
did it cost to make this movie? How long is it?
Okay, so the cost is not much really. It is like basically around, you know, in the tens of thousands of euros, basically. So it's not like even 100,000 euros. We're talking about, you know, actually the most expensive thing was the location, which was very hard to get, you know. But yeah, we're talking, you know, around the 20,000K, something like that. And the duration is 16 minutes. Okay, so this is a 16-minute. It's a short film, but for a short film, it's quite long. It's 16 minutes. Yeah. Okay,
so I make a prediction that you will be hired by Hollywood to make movies, because this is bringing down dramatically the cost of making movies with digital tools, and the quality can be actually much higher. So that's going to be an interesting future.
No, this is true. This will lower the costs dramatically. This is right. This is true.
What was the most, in a sense, I would like to ask, what was the easiest thing? What was the easiest thing to do that it is normally very difficult to do with traditional ways?
Yeah, great question. I think the most, okay, for example, there are many things actually. The NERF thing is one of them. You know, if you want to reconstruct a 3D space, typically you used to use photogrammetry. You know, many of you will know about photogrammetry. Now, photogrammetry can be a pain. You have to, it's very time consuming. So NERF is like, for example, if you want to preserve the light reflections with photogrammetry, is basically impossible, especially as you move around. This is not going to happen. So with NERF, you can do it much faster, but you can also do things that are simply impossible with the previous technique, with photogrammetry. You know, you can move around and the light changes, the reflections on the table, whatever. It was simply impossible. So it's faster and it allows you to do things that were impossible before. So I would say NERF is the most impressive one, you know. Then the other thing that is definitely very impressive is when we are generating videos or images, is how much you can, again, how much you can experiment and try different things in such a short time. In the past, if you wanted to express a certain concept visually, it would take you just hours to try one thing. And when we were generating with our RTX 3090 NVIDIA graphic cards, we could launch multiple things simultaneously. We could start and stop things, try different prompts, and this is a massive change. Again, it's in the productivity, brainstorming, prototyping phase of things. This is where the massive change as well is. Yeah.
And what is the thing that is still difficult today to do when you want to make a movie, other than paying the location?
Yes. Yeah, I mean, definitely, but it's very funny because whatever I tell you, it will probably be super easy in 6 months, right? Because I'm going to tell you that, for example, Runway ML just launched Gen 2. So Gen 2 is the second version of their text to video model. Okay. So Gen 2 is way better than Gen 1. Okay. But if you look at the results, the texture, the transition between the frames is still not very good. There's kind of like an instability, when you go from one frame to the other, it's not completely continuous. And the resolution is also still not very good. So those are things that it still doesn't reach what you can do with a normal video camera. But again, if we go 1 year in the future, it will probably already change. But this is definitely a thing that if you want to make him, and that's why that's why our movie has real actors. It's not like a whole movie made with generative AI, because and there are people doing things now, but you look at them and the quality is just not there yet for video. It's not there. But again, in 1 year it will be different. Yeah.
You mentioned, I mean, there's probably many questions about the whole GPT thing, not the technology, just what's happening around it. You mentioned that Anthropic already posted a career as prompt engineer. The salary is 175K to 335K.
Yes.
Are you going to apply? No, that's not the real question. The real question is, what will the prompt engineer do?
Yeah, it's very interesting to see at the requirements of the job. Because when you look at the requirements, it gives you a clue of what it will do, because the requirements have very little technical things in them. They tell you should be like a hacker, a very creative person, you like to solve problems, you have basically a lot of diversity in your life, whatever. So basically, prompt engineers, for me, it's an art and a science. What do they have to do? It's very difficult because in the engineering part, they need to understand a lot these architectures. They need to understand how they were trained, what data sets they used. So basically, what are their strengths and their weaknesses? All of this is the engineering part. But then there is the art part. This is like when you meet a new person. And, you have to understand that person, and maybe you find what is the best way to communicate with this person to, reach some objective. And they will have to do the same thing with AI architecture. It's like meeting a new character, a new person. What is the best way of communicating with this guy or with this girl in order for this guy or this girl to do this for me, And that's an art, basically. So you need people that are very intuitive and creative and problem solvers. And it's not easy. Prompt engineering is going to be a difficult job. Yeah.
And by the way, you also mentioned Alpaca.
Yes.
It's the one done by Stanford, right?
Absolutely. Yes.
So that one cost $600 to make.
Yes.
So they made a clone of ChatGPT with $600.
Yeah, it's incredible. And now I have it in my home. I have it installed in my home. And it's unbelievable. I mean, so it's under my control, and that's an incredible feeling. And, if you test it, it's pretty good. You can say, it has a system prompt as well. You can say, okay, pretend that you are Leonardo, and then you have a chat with Leonardo da Vinci, and you ask things about how did you create Mona Lisa, what are the secrets behind, and it's pretty good. It's not very different from interacting with ChatGPT, and you have it at your home. So this is what gives really the feeling of how fast everything is moving, right? Like in a few months, everybody can have a ChatGPT in their homes, and not only that, the most important thing is what I told you guys before, is that they will connect these entities to a lot of other tools that can do a million different things. And then we go to this, is the network effect. You know, a lot of people ask, why are you guys worried about this? Is the network effect, you know, that didn't exist with other things. How fast all of this interconnection can happen, yeah.
Yeah,
But,
probably the biggest thing they have to fix in the chatbots right now is the hallucination.
yes.
I find it very easy to create problems with these things. I just ask obscure things, obscure facts, where it's really hard to find out what happened. And sometimes the chatbot is smart enough to say, I don't know. Sometimes it makes up things and you have no idea. I mean, I ask questions about obscure silent movies of a century ago, and the ChatGPT came up with a plot, with a very detailed plot that is totally false, totally made up, but so credible.
It is absolutely disconcerting. Yeah, and you know, it does it in the book of Kahneman, Thinking Fast and Slow. It tells you that our system one, our subconscious, is a bit like this, right? The subconscious, it sends impressions to our system two, and it always sends them as if they are the total truth. Even so, when our intuition is wrong, it still is sent to our system two. This is the actual truth. And if you're a very reactive person, you believe it and you act on it, and sometimes you make huge mistakes. So it's the same thing that you are describing. You know, ChatGPT makes all these associative statistical connections, and sometimes they are so wrong, but it presents them to you with such a confidence. It has happened to me so many times as well. And this is dangerous. Yeah, this can be super dangerous. So
it's interesting. I mean, it's well,
I mean, it's not very dangerous right now, not right now, but you know, if you extrapolate when these systems are next level.
I actually think that's what human beings do. We made up a lot of things when we don't know.
Absolutely, that's what we do.
Check the Q&A. I have to do something behind me.
Okay.
Check the Q&A.
So let's see the Q&A. Okay, so Catherine, yes, Catherine, this is being recorded and will be shared. Yes, indeed. Thank you for being there. Applications for dance. Okay, and Christine, I will also address you. Okay, so first, applications for dance. Applications for dance. Well, I can tell you that the nerve technology at the moment is only for static environments, but there are already people working and doing research to apply it to moving characters as well, you know? So eventually, you should be able to reconstruct 3D environments with moving people as well with this technique, which would be quite interesting, you know? Applications for dance as well, yes. You could use as well. For example, you could fine-tune stable diffusion with you know, the look of an actress, and then you know, generate new images or videos of that actress, of that dancer. Generate images or videos of the dancer within completely new environments. By the way, there is another great application for dancing that this is already of a few years ago, that you can use a neural network to learn the movements of a professional dancer, and you can apply them to the image of a completely different person that is not a dancer. And you can transfer the dancing movements of a person to a completely different person and create a video of the other person moving like the dancer is moving. So this sort of thing as well. Okay, Christine, is this recording? So pictures of actress again. Okay. Okay, I will do that. So let's show the pictures of the actress. Oops. Okay, well, let me go. Okay, let me see if this works. Wait, my computer is getting. Okay. Oops. My computer is going a bit nuts. Okay. Wait, I'm trying to go back and it's going forwards. See if I can exit.
Well, it's recorded, so they can.
Yeah, I think it's not a good idea. It's going crazy. Okay, anyway.
Get the last question.
Okay.
You see the question from Terence?
Can you read it? Because my computer is going completely crazy.
Okay, I can read it, but it's very teeny. Do you foresee someday such a movie that is different every time it's watched? That all roles are done by GPT AI, even prompt engineering? multiple inputs to the data, but control sabotage? If so, will it be a good movie?
Okay. Hello?
Javier, I think we are losing you.
Yeah, can you still listen to me?
Yes.
Okay.
Did you hear the
you can still
question?
listen? Yeah, I heard the question. You can still hear me, no? Okay,
Yes.
because my computer is going nuts. Okay, that is a great question. That is a beautiful question. Yes, this will be possible, 100%. Okay, this will be possible. In fact, I used to have a dream years ago of, like, you know, when you would watch a movie, depending on your emotional state, movie would change. So, you know, if you were sad or you were happy or you were excited, the contents of the movie would change. And this is going to become possible very soon, because with generative AI, you will be able, first of all, there are already people that have built technology to detect emotions, right? They can, look at your human face watching the movie, and they can detect your emotions. And now you will be able very soon to, in real time, do generation of, so basically you could have a movie that is described with language. Okay, so you have many prompts that describe the movie, and then in real time you can generate different expressions of the concepts of the movie depending on your emotional state, for example. And is this going to be a good movie? Of course, because I mean, a good or bad, we don't know, but the quality of a movie is always going to depend on the storytelling, the script, right? And that's not going to change. The only thing that is going to change is that a lot of scripts in the future are going to be written by AI, of course, either by collaborating with a human or fully by AI. But yes, the answer to the question is that this is absolutely very much possible, and it will probably happen sooner than we expected. If you asked me this question, what is very interesting is that if you asked me this question 3 years ago, I would tell you, oh, well, I think that's quite far in the future, you know. But if you ask me this question today, after the crazy acceleration of the last year, I tell you, this is going to happen, and it's going to happen pretty soon, because there are so many people researching right now and advancing this stuff that is going to happen within a few years max. You know?
Okay, your video keeps freezing, so it's a sign that it's about to end.
I know it's going crazy.
That's probably the internet. Okay, thank you very much, Javier. And
thank you very much.
Evening,
it's been such a pleasure.
Good night to you.
Thank you. Good night. Thank you. Thank you very much. Thank you, Pedro. Everybody. Thank you.